Hey guys, it's Brandon, and today I'm going to show you how to do problem number 52 in chapter 13. So first we read the problem. The maximum distance from the Earth to the Sun at aphelion is 1.521 times 10 to the 11th meters, and the distance of closest approach at perihelion is 1.471 times 10 to the 11th meters. The Earth's orbital speed at perihelion is 3.027 times 10 to the 4th meters per second. Determine A, the Earth's orbital speed at aphelion, B, kinetic and potential energies of the Earth-Sun system at perihelion, and C, the kinetic and potential energies at aphelion. Is the total energy of the system constant? Ignore the effect of the moon and other planets. So, first I drew a picture. So, when it's at aphelion, I'm going to call the distance the Earth is from the Sun RA, and that's equal to 1.521 times 10 to the 11th meters. And when it's at perihelion, I'm going to call that distance RP, or 1.471 times 10 to the 11th meters. And from the problem, we know that the velocity at perihelion, VP, is 3.027 times 10 to the 4th meters per second. So in part A, we are solving for the Earth's orbital speed at aphelion. So because torque is equal to 0, we know that the angular momentum is conserved at aphelion and perihelion. So we can say that the rate RA times the mass of the Earth times the velocity at A is equal to RP times the mass of the Earth times VP. And we can cancel the mass of the Earth from both sides. And since we're solving for VA, we get VA is equal to RP times VP over RA. And plugging in our numbers, we get 2.927 times 10 to the 4th meters per second. Now, in part B, we're finding the kinetic and potential energy at perihelion. So for kinetic energy, that's equal to 1/2 times the mass of the Earth times the velocity at perihelion squared. And plugging in your numbers, that gives you 2.74 times 10 to the 33rd joules. And your potential energy is equal to negative gravitational constant times the mass of the Earth times the mass of the Sun times divided by RP. And when you plug in your numbers, you should get negative 5.40 times 10 to the 33rd joules. Now, moving on to part C, we're solving for the kinetic and potential energy at aphelion. And going through a similar process to part B, for the kinetic energy at aphelion, we know that's equal to 1/2 times the mass of the Earth times VA squared, and plugging in the numbers you get 2.56 times 10 to the 33rd joules. And the potential energy at aphelion is equal to negative gravitational constant times the mass of the Earth times the mass of the Sun divided by RA. And plugging in the numbers, you should get negative 5.22 times 10 to the 33rd joules. And the last part of the question was asking if the total energy of the system is constant. So to determine this, we find the total energy at aphelion and perihelion, and you can do that by adding the kinetic and potential energy at each point respectively. And we find that they're the same, so therefore the energy total is constant. There you go.